to show
This
you how to change the
conference will
label.
now be recorded.
So please try to understand. Okay, so here I'm going to click here from CSV. I'm going to import a data set. Either I can write it from here with respect to my path, everything, but here I'm going to use it as import CSV. Import data set from CSV. I think my system is asking for some packages to be installed. By the time it installs, we'll see. So this is your data set for today's session. This is your data set for today's session. Try to understand the data. So this is my ID. That is nothing but your patient ID. And this is your patient diagnosis, what the particular patient has been suffering with. The data is with respect to cancer data set, which is the latest project whichever I worked in my company organization. So you can see this B stands for benign cancer tumor, and this is M. M stands for malignant tumor. So B is nothing but your benign tumor, which is non-dangerous. Remember, write it down now itself. B is benign tumor, which is non-dangerous, and M stands for malignant cancer, which is cancerous plus dangerous tumor. Cancerous plus dangerous tumor. If a person is suffering from malignant tumor, the chances of surviving will be very, very less. Chances of surviving will be very less. And remaining things are the parameters. Remaining things are the parameters. These are the parameters of the tumors. Radius, mean, texture mean, perimeter mean, area mean, smoothness mean, all these are the parameters of the tumors. So after reading it, all this medical data, you should classify whether a patient is been suffering from benign tumor or malignant tumor. Benign tumor or malignant tumor. So it is also your classification algorithm. As I told you in the previous session, KNN is also your classification algorithm. One is B, another one is M. Benign and malignant. Benign and malignant. So let me close this data set and let me I don't know why I'm getting this error. Just give me a sec. Let me just install a package called as rlang. rlang. Let me choose the path itself. That would be better. That would be try it out in this way. Could not find function read underscore CSV. No idea why it is. Okay, so I need to install some packages. I think I need to update some packages. So that's the reason read underscore CSV is giving me a problem. So let me just say how many packages needs to be updated, because I've not updated from past 10 days probably. So there might be, okay, so there are multiple packages that needs to be updated. So that's the reason I'm getting an error. So I'm going to use a function called as read.csv. By specifying the path, I'm going to store this file called as wbcd in a variable called as wbcd. This is the data set name. I just given some random name. That's it. There is no any meaning behind that. And the first first column is called as your patient ID, and that is something like your patient number. That's it. Patient registration number or member number. That's it. And this is your output column. You need to identify whether a patient is being diagnosed with B or M. So B stands for benign tumor. Benign tumor is called as non. You can use both. You can use both read underscore CSV or read.csv. Both are there, but read underscore CSV is not working because there is some package mismatch. So that's the reason. Benign tumor is non-cancerous and malignant tumor is cancerous. Malignant tumor is cancerous. So based on this, we are going to implement an algorithm called as K nearest neighbor classification. Remaining totally you are having, the observation is 569 patients data and you're having 32 columns. 32 columns are nothing but your variables. So here, if you see this view of WBCD, it again opens the data set. Let me just run it once. So you'll be able to see your data set. That's it, nothing else. There is no any rocket science. So on this one, what is this line gives you?
Structures.
Structure. Satish, be on mute. There is a lot of disturbance from your end. Yes, it will give you the each and every column, what type of data it is for each and every column. So let me run this line of code str of WBCD. See, totally we are having 32 columns, right? All the column names, what type of data it has been displayed. Number, number, number. And also you can see that first column is called as your diagnosis and member ID, right? So you might see that 569 observations, 32 variables. First one is ID integer. Second one is diagnosis with factor level, because you're having only two levels, right? So this is your B and M. B is identified as 1, M is identified as 2. This is your structure function test. So dim of WBCD will give you the total number of rows and columns in your data set. 569 observations, 32. If you can see here, it is same rows and columns. Rows and columns. Now, coming to this point, ID column can be removed. See, because I don't want this first column called as patient ID, because it doesn't make any sense. If I tell a register number of a student, I cannot tell whether he is going to pass or fail in exam. So if I tell a membership number of a patient, I cannot tell whether he is being diagnosed with benign cancer or malignant cancer. So I don't want that. I'm going to remove that particular column called as patient ID. That is your first column ID. So this one I'm writing it as in this format. It is WBCD minus 1. WBCD of minus 1 in the sense I'm removing the first column and storing it in the same variable called as WBCD. Now it will become 569 into 31 observations. See here, 569 into 31 observations. You can see there is no first column called as ID. ID is not there. Dimension, it is 569, 31. So now coming to this point, coming to this line, WBCD dollar diagnosis. What it will give you? So if you write a function called as table with respect to WBCD dollar diagnosis column, they are going to give you, it is going to give you how many types of patients are with respect to benign, how many types of patients are with malignant, how many types of patients are with malignant. So out of 569, you might have 300 here, you might have 269 here. In order to check that, we are using a function called as We're using a function called as table. That's it. See, function gives you B. Benign is 357 patients. Malignant patients are 212 patients. If you add these two, you're going to get 569 patients. 569 patients. And this particular column will give you, this particular column STR of WBCD dollar diagnosis will give you what? B, M were there, right? So what is this particular column structure? Data type of this particular column will be displayed. It will display as your, what? Factor. It will display as your factor, because we have already seen with respect to that, right? So you can see that factor with two levels, because you're having only B and M. B is recognized as 1, M is recognized internally as 2. For you it will be B and M only. For you it will be B and M only, but your system will understand B as 1, 2 as M. If you want, you can change that name
Yogesh,
also. Yes, Rakesh.
Yogesh, can you please show me the data set again?
This is your data set.
Okay, so okay, so table of WPCCD diagnosis. So based on diagnosis, it's going to
Yes,
display
based
what
on
is B and
diagnosis
how
column,
many records B
how
and how
many
many
B's are
records.
there, M's are there. In order to get your unique records, if you're having, for
Okay,
example, if you're having three colors, red, blue, green, out of 1000 records, how many records are having red color, blue color, green color? You can use a function called as table color column. Got it? Yes, it's same as
okay.
classification. That's it. Now,
What this STR will do?
STR will display the type of column, what data type it is. See, it will display it as a factor data type. Factor means it is having only two classifications, B and M. If suppose, if I, instead of writing it as diagnosis column, if I write some other column, so let me change this. Instead of diagnosis column, I'm taking some other column. WBCD dollar radius mean I'm going to take. It will display some other thing. The type of data set. Here it is number,
Numerical.
numeric. Yes. Got it?
But okay, diagnosis only B and M. Okay.
Only diagnosis is your B and M.
So that one is in what position B is there and what position M is there? Is it?
No, 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 no. B is considered as 1. If you are having B, wherever there is B, it will be considered as 1. If you are having M, it is considered as 2. Classification, that's it.
Okay, in the diagnosis table.
Yes. If it is B, it will be read as 1. If it is M, it will be
Okay,
read as 2 internally.
got it.
Okay. Now coming to this line of code. So actually already it is in the form of factor. So once again, I'm just using this factor. If suppose it was not a factor data type, suppose it was not a factor data type, you can use this function called as factor. Okay, factor will convert your data set into factor type. You are using a column called as WBCD dollar diagnosis column. Convert this into factor. Convert this into factor. And how many levels we have in your data set? We are having how many data set levels? It is only 2 levels. You can specify here how many levels we have. One is B and another one is M. So you don't want to display it as B and M. You want to change this into full form. You want to change this B and M into full form. This is your additional optional part, what you can change. Instead of writing B, you can write full form as benign. Instead of this M, you can write it as malignant full form by using this particular line of code. See, again, you need not have to use this factor, but if it was not a factor data type, you need to use this. You need to use this. See here, labels is equal to, instead of B, I'm changing it to benign. Instead of M, I'm changing it to malignant. So that's it. And replacing with your original dataset called as WBCD is your dataset name. Diagnosis column, I'm going to replace with that. Now, if I run this table of WBCD dollar diagnosis, it is going to give you, instead of B and M, here you got it as B and M, right? The same will be there, but instead of B, it will be displaying it as benign and malignant full form, because we have changed the name to B for benign, M for malignant.
Yogesh, the
Yes.
factor will converting. You're saying the factor function will convert the
See,
if the
factor
data is
function.
not.
Yes, factor function will convert if the data is not in factor format. If the data is in numeric format, if it is in integer format, if it is in some other format, if you want to convert that data type into factor, you can use a function called as, directly you can use as dot factor, or you can directly use it as factor. Both of them are there. Both of them
But
are
the
there.
but you suppose if it's a numeric is there, and suppose
Yes.
2.4, 2.5, 2.6 or something is there, I need to define
Yes.
the levels also, all the number of records.
So this is something like your optional part.
Okay.
Optional part. This is, I'm just showing for, see, if you're having, one sec, let me just come to this. If you're having 1, 2, 3, this will be level, this will be level, this will be level. I can put it as red color, blue color, green color. Okay.
Hmm.
And if it is like this, 1.1, 1.11, 1.21, 1.31, will you convert this into factor? It doesn't make any sense, right?
Yeah, right.
Yes. So you should understand what type of data and which particular column you are converting it into, either factor or something else. At that time, it will be useful. If you're having any classification columns like gender, gender will have male and female. For example, type of car will have like petrol car, diesel car, CNG car, LPG car. Like this, you want to convert this into factor, then you can use a function called as factor of type of car data column name. You cannot use for numeric value. If it is like float, you'll have multiple values. For age column, one person is 18, another person is 19, 20, 21, 30, 35. Will you use for this? It doesn't make sense, right? Each and every person will have different age. It doesn't make sense. But if you're having a column called as gender here, male, female, male, female, 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 like this, for these type of columns, you can use your, for discrete data type. Discrete, both are discrete. It doesn't mean that age can also be 18.2, 18.5, 19.3, like this. But the thing is, if you're having categorical data like this, male and female, then you can go for factor. Then you can go for factor.
So for the same thing, if I define labels, so that
Yes,
would be male and
obviously.
female, correct?
If you are having M for male, F for female, that's it.
Right.
Whatever
Okay.
names you want, you can specify. Here, instead
So it
of
will
benign,
just
I can specify whatever I want. Here also I can specify male and female. It is you are defining the name, right? You can specify
so
whatever you want.
so on the output it will display this name, not the
Yes, see
uh,
here, it is displaying this name. It is
right.
displaying
Okay.
this name.
Right.
One sec.
Okay.
Ranjit, I'm in class. Ranjit, I'll call you back. Now you can see here, earlier it was B and M, now it is displaying as benign and malignant. Benign and malignant. Now, so I want to see the proportion. I want to see the proportion out of 569 patients. What proportion? Around 65%, is it benign, or is it 35% malignant? I want to see the proportion of the percentage of the patients. Okay, now see this. I'm going to use a function called as table WBCD dollar diagnosis. Already we know that you are going to get 357 and 212 for this. So you are doing that proportion of table. You are using a function called as prop dot table. If you use that, it is going to calculate your proportion. So it will be like this: 357 divided by total number of records is 569. How much is 357 divided by 569?
Point something.
Point something. What is that something?
0.7.
0.62.
0.62. Yes.
Yeah.
So it will give you 62% proportion. What about this remaining 212 divided by 569? So it will give you the proportion of these two.
0.4 something, I think.
Right, it is going to give you the answer. So if you want to check what is the proportion, see, consider that you're having 100 students in a class. You want to see how many boys are there. So around 65% boys, remaining 35% are girls. You want to check this, you can use a function called as prop.table and take this diagnosis. If you do into 100, it is going to give you, instead of giving it as 0.67, it is going to give it as 67.25% or whatever it is, and you're rounding off your decimal digit to 1 decimal point. So let me run this line of code. Let me run this line of, it is just for your understanding, that's it. What all we can do using R. See, 62.7% is benign patients, malignant patients are 37.3. So if I remove this, you are going to get only one digit, because I mentioned digit is equal to 1. It will be 60%, it will be 40%, because I've mentioned it as only digit 1. If you clearly mention it as 4 digits or 3 digits, let me put it as 4. See, exactly you are going to get similar to this. 62.74, 37.326 is rounded off to 3. Clear? What is this particular line of code will give you? It is going to give you the proportion of the classifications. How many classifications? Total number of proportions out of 100%. Out of 100%. Prop dot table. And if you want, you can use this into 100. If you want use, if you use into 100, it is going to give you like this: 62.7, 37.3. It is up to you whether you, how you understand.
Initially, digits was what value? Did digits 1?
Yes. Yeah.
Minus 1. No, 1, I think.
Yes, it was. I had given it as 1, right? See here. Digits equal to 1. If I'm going to run this, you're going to get it like this. Or else I'll put it like this: 2. See here. Clear?
Okay. So what is the function of round here, Yogesh? Because in the previous thing,
Round. So here, round will round it off to 2 decimal point, Rakesh.
okay. I thought it'll take the nearest, I mean, next highest value. Round off means.
Round off means
So
next highest value. If you don't specify it to 2 digits, it is going to take it as next nearest value. But we are specifying it as digits is equal to 2, right?
so
Then
it will that will override. Digits
yes,
will over.
yes.
Yep. Okay.
Okay. Yeah, you can use all those functions. We have we have all, we have seal, all these functions we have. And also you can do multiple things are there. Whatever is necessary, I'm going to show that part, Ratnesh. Now, coming to this. So after doing this, okay, I've not done this line of code. I'm going to do standardization. I'm going to do standardization. need to do standardization. I want to do scaling. I want to do scaling on my data set. So before that, I want to show you this part. See a summary of WBCD of 3 columns I'm taking: radius mean, area mean, and smoothness mean. So if you see this, the minimum is, this is 6.9, this one is 143.5, and this one is 0.05. So do we have scaling issue in this? Yes or no? One is in units, another one is in decimals, another one is in hundreds. So you can see that there is a unit issue. Sorry, scaling issue. Apart from that, radius mean will have different unit, area mean will have different unit, smoothness mean will have different unit. So one is scaling issue, another one is unit issue. If you're having these type of issues, what you should do is you should go for standardization. You should go for standardization of your data, because I could not display all the columns. I've just taken 3 columns out of 31 columns. So now your data is having problem with respect to your standardization problem, scaling issue and your unit issue. So we need to do standardization. So for using standardization, I'm going to use a function called as scale function. See here, this line of code, WBCD underscore STD standardization. I'm using a function called as scale. Scale is a function, and here I'm specifying from which column to which column. From my data set called as WBCD, from second column to 31st column, I'm doing scaling. So what about first column? Rakesh, Manju, Bharat, Lahari, Ranjini.
First is a classification, no? Diagnosis.
Yeah, because it is your diagnosis column. It is not, you should not tell it as classification. You should tell it that it is your non-numerical data, non-numerical or categorical data. So you cannot calculate mean, right? You cannot calculate mean for your B and M. So that is the reason you cannot do standardization for your categorical data. So we are not including that column. Remaining all the columns, we are including it. Remaining all the columns, we are including. So I'm going to do standardization. Now I've standardization done it. I am just opening your standardized data set. See, now everything is standardized. Now I'm going to run this line of code called as, once again, I'm going to run a summary function on these 3 columns. Instead of taking WBCD, I'm going to take it as WBCD underscore STD. See here, once again, I'm going to run this line of code. WBCD underscore STD. Okay, can I know why are you getting this type of error? Because it is not in your type of your data frame. So that's the reason you're getting in this way. WBCD underscore standard is not in your tabular format. That's the reason you're going to get it like this. So we need to convert that into tabular format. So how do we convert that into tabular format? How do we convert this data set into tabular format?
As data
Next.
frame.
Yes, as data frame, you can use a function and you can convert that into tabular format. So WBCD underscore STD. See, it is in your matrix format, so it is not able to show your minimum, first quarter, median. So I need to convert that into your data frame format. So I'm going to use the same data set name called as STD. WBCD underscore STD as dot. See, if you type it as dot data dot frame, you are going to get it. You can choose here the column name. So not the column name, the variable data set name WBCD underscore STD. So I'm going to, WBCD underscore STD. I'm going to execute this. So once after I execute this, and once again if I run the scale, now it is going to be displayed as data frame. Data frame. So now I can run this line called as radius mean, area mean, smoothness mean, standardized data. So now you can see all of them are standardized. Earlier it was something, it was something, it was something. Now almost everyone are close to each other. Almost everyone are close to each other. Your scaling issue and your unit issue has been solved. Unit issue has been solved. Now I'm going to split my data set. So now I'm going to split my data set into two splits. One is called as training. Training is used for building the model. Something like your dev environment, you can remember. Don't use dev and test in your, if you go for an interview, don't use a word called as dev and test. Use it as training data set and test data set. Why it is used for training is, training data set is used to build your model. Test data set is used to test your model. Test your model. So now we are having approximately around 569 observations. Here I'm going to show you in a simpler way how we can do your split. So split, I'm going to use a function called as, directly I'm not going to use any inbuilt function. So in a simpler way, wbcd underscore train, wbcd underscore n. Okay, see I'm going, what is this wbcd underscore n? It is your standardized data. Sorry, we need to change this variable name. wbcd underscore std, right? Std we created just now. So this is your wbcd underscore std. So I'm going to use that data set, not all the rows. I'm choosing how many rows here out of 569. I'm choosing only from first record to your 469 records. I'm going to put it into a variable called as wbcd underscore train. Remaining from 470 to 569, I'm going to put it into a variable called as wbcd underscore test. wbcd underscore test. And I'm using all the columns. Here comma means it is all the columns. And you can see, so if I run this line of code, what will be the dimension of this, Rakesh or Larry?
It'll show rows and columns, right?
469 into 7.
Yeah, rows and columns. I'm asking you the dimension. If I run this, what will be the output?
469 into
Into that
11
one.
columns. 11 columns.
11 columns.
10, sorry, 10 columns.
10
10,
columns.
9, 9.
From where did you get 10 columns? 9 columns?
No, because from normalized data.
So how many
Standardized
columns we have
data.
in total data set? See here.
31. Sorry.
After that 31, we have removed one diagnosis column, right?
30.
Yeah.
469.
It is 469 into 30, right?
469
Yeah.
30.
See, this is your standardized data train. So now if I run this line of code, from 470 to 569, I'm going to put it into a variable called as test. So what will be the dimension of this? Sorry, I need to change this to std. std. Come on, tell me. What will be the answer for this?
100, 30.
It is
99.
see, when you should see, who is this? See, always I told you, if I'm using a dim function, see here. Don't tell blindly 99, 39, 100, 9, 10, 11. Your answer, if you're smart enough, you'll be able to see your global environment window and you can easily say that it is 100, 30. Told you multiple times. I told you multiple times. It is your 100 rows and 30 columns. So now you should use your training model to build your data set and test model to build your, to test your model. Test data set to build your, to test your model. Now, you should also choose first 469 rows output column, that is your diagnosis column, into a separate data set, and this remaining 100 columns diagnosis column into separate data set. Create two data set called as labels. Create two data sets called as labels. See here. WBCD underscore train underscore labels. I'm going to choose 1 to 416 all the records and first column. First column. What will be the dimension of this if I run this line of code? It is simple, very, very simple. What will be the dimension of this line of code 48, line number 48?
Should be 469, 1.
469,
Comma 1.
comma 1.
Yeah.
Okay. Yes, it will be 469, comma 1 because you are choosing only one column. So I'm going to run this WBCD underscore train underscore labels and show you what is there in this 469 underscore, sorry, WBCD underscore train underscore label. See, it is only having benign, malignant. That's it. Totally 416, all the records will be as your factor level. It means you are choosing a separate column for your data set. That is your factor level. That is your diagnosis column. And see here, I'm converting that into factor. It is already into factor. I need not have to run this. So just for default purpose, I've kept it. This default purpose, I've kept it. So if you see this structure of WBCD underscore train underscore levels, it is showing it as factor with two levels, benign and malignant. Now, what does this line of code does? Sorry, this line. Sorry. This part, this line number 51.
So it creates list of the records and selects only the first column.
Yes, of your test part, not your training part. It is from 470 to 569.
Yeah.
It is going to choose the first column called as diagnosis and store it in a variable called as WBCD underscore test label. It will be of your dimension 100, 1. 100, 1. So now if you see that, that will also be in your factor type. That will also be in your factor type. That's it. Now, after doing all these things, still now whatever you have done is splitting your data, you're cleaning your data, your columns removal, standardization, scaling, everything you have done. So now you are going to implement an algorithm called as KNN. So for implementation of your KNN algorithm, I need to use a package called as class. Already installed this package. I'm using that package. Now for implementation of your KNN algorithm, there is a function called as KNN. There is a function called as KNN, and you should specify the parameters. What are the parameters you should specify for your KNN algorithm is, first is your training data set. On which data set you should build the model, that data set. That is your training data set. Second one is on which model you should test this test. On which data set you should test your model, that is your test data set. Test data set. And after building this model, it will predict some values, right? Benign, malignant, right? So then you should compare with your original labels, right? Whether this is also B, this is your predicted, this is your actuals. B, M, B. It will compare B, same, MB fail, this is fail, this is fail. So that one you should specify as the classification of your data called as labels. We created WBCD underscore train underscore labels, right? So that one also you should specify. It is somewhere below. It is somewhere below here. This one, WBCD underscore train underscore labels. And randomly I told you that you should specify the K value. You can specify 10, 15. I'm going to specify it as 10 or 11. K is equal to 11. And then I'm going to store this output in a variable called as WBCD underscore test underscore pred. You can give it as model, model 1, model 2, whatever you want, you can give. So I'm going to implement this algorithm and store it in a variable called as WBCD underscore test underscore pred.
Yogesh, can you repeat once again this one?
Which one?
So,
This line.
57. Yeah.
Yeah. KNN is a function to implement your K nearest neighbor algorithm. One sec. First, you should pass your training data set on which particular data set you want to build your model. Okay. Second is WBCD underscore test on which data set you should test this model. First, you should specify the model on which your KNN algorithm has to be built. That is your training data set. After building this model, which model you should test it? WBCD underscore test data set. And then on which particular column you should classify, right? Your output should classify, right? Once you are building, why are you building? You should classify whether a patient is being diagnosed with B or M. So you should specify that training underscore labels also. Once this has been built, it will see my prediction is incorrect with your labels. So that is your third parameter. That is your classification parameter. Got it? And this K is equal to
Nearest.
yes. So here I'm specifying K is equal to 11 as my testing. So nearest neighbors. So I'm going to run this line of code. Okay, I'm getting an error. Train and class have different lengths. Just give me a sec. Let me try to see what is the different length here. Structure is malignant with 1. This is also factor. This is fine. This is fine. Train underscore test underscore labels have different lengths. Both are same, but where are we getting this error? Class is equal to WBCD underscore. Okay, line number 48. Line number 48. No, we have run this, right? We have run this. Oh,
What exactly does it mean when it mentions as length? Is it column,
no, it is not column. It should be with respect to your row wise.
row wise?
One sec, let me check. Because we are having same, right? Okay, WBCD underscore STD. Yes, I think I have done the mistake here. Oh, sorry, it is correct. WBCD is correct. That is no problem. It was working. I checked it multiple times. There's no problem with the coding part. So let me just check it out. Hmm, I don't see the issue, but I'm getting the error. Without access to the data, it's really hard to help. Train underscore points, test underscore points shouldn't. No, answer, the steps are correct. I'm 100% sure about the steps because this is my real-time project model. I built it. No, see, try to understand here. I'm not going to use my, see, train underscore labels, what it is having. Train underscore labels is having what? Train underscore labels is having what? It is having your diagnosis column. Diagnosis column. And this one is going to display your diagnosis column conversion. That's it. But that is what you are getting an error here. So,
Is because of the number of records in different size.
so no, that should, obviously you're having only one column, right? Here you're having only one column, right? Factor with two levels. Okay, let me just try to okay, let me just see this. Class of it is also factor, and this is also showing it as factor, and this one is showing it as structure of malignant 1, and this one it is showing it as STR. It is also correct. Benign and malignant factor with two levels, both are same. But train underscore, no. Just give me a sec. Let me just change it to data frame. Data dot frame, and this one also I'll change it into data dot frame because this shouldn't be a problem generally. Data dot frame. Okay, one observation of one variable. Oh, okay, fine. You're getting only one record. You're getting only one record. That's the problem. Fine. So the problem here is it is taking only one record. So I'm going to run this once again. WBCD underscore train underscore labels should have all the 1 to 469 records, right? So convert that into yeah, I'll just I'm checking. It should be a factor only. I'm just doing some WBCD underscore train underscore labels. Just give me 1 sec. Oh, it is taking only one column. WBCD underscore train underscore labels. It is taking only one column. So what I'll do is here, Kushi, just give me a sec. Let me just try to do some manipulation of your data set and show you. WBCD
After
is your data set. That is fine. So I'm going to create one variable called as WBCD underscore WBCD1, and I'm going to just put that. Okay, so you can see WBCD1 I have created here, and WBCD1, let me check the classification here. Classification, not classification, class. Yes, it is your data frame. So you can see here
okay,
it is having 569 observations of 31 variables. Now I'm going to choose this WBCD 1 to 469 columns, and first row,
one is
first column, all the rows, first column, I'm putting it into a variable called as WBCD underscore train underscore labels 1. I'll put labels 1. I'm going to put here. I'm converting that into your data frame. Okay. 469 observations of one variable. See, labels underscore 1 is having correctly. Now it is correct. Now similar way, I'm going to change this. STD data is fine. STD data I'm not changing because I'm just creating the labels. I'm just creating a label. Just creating a label. First column, diagnosis column, I'm creating nothing else. From 470 to 569, I'm going to take this and I'm going to create a WBCD underscore test underscore 1, labels 1. So let me see here. WBCD underscore test underscore, this is test. Let me choose one column where it is. See, again, it is taking it as WBCD underscore test underscore labels. It is test. It is STD. Okay. Okay. So this one, I'm going to labels 1. I'm going to run this and store it in a variable called as labels 1. So now you can see it will be 100 observations of one variable. See, now it is correct. So now it is correct. Let me try to see the class. It is in your data frame. That is also in your data frame. Will it work? Let me see. Now also it is having same problem. So what I'll do is now,
no, it should be one. No,
what?
the variable you are
What should
given
be
is a
one?
one.
Fine, but
WSTD
I've
test.
taken, see now here, you can see here, WBCD underscore, see here, train underscore labels 1. You're having correct, right? Benign, all the columns. WBCD underscore train underscore labels. So I'll just execute this line of code. See here. 469, you're having this. And if you execute this WBCD underscore test underscore labels 1, you're getting this. That's it. You're getting 100. It is correct. But the thing is, it should be of type
Data frame.
factor. I'm just executing this and checking it out, whether it is correctly working or not. And this one here, I'm going to change it into as dot factor. X must be numeric. I will call sort. X must be atomic sort or sort dot list. As dot factor WBCD underscore test underscore labels 1. I will call this sort on a list. It is at list. It is also data frame. So let me just once again open this data set, the coding part. Let me try. Just running from first once again. Let me clear all these things. I'm going to import a dataset from my CSV format. Let me just do it as app. Yes, it is imported. View of WBCD done. So here I don't want to do all these things. I'm just running this part. I'm just running this. I'm just running this. I'm just running this. Okay, I don't want to see this and all. I don't want to do this. Either I can use a function called as scale here. Then I can see WBCD underscore STD. Okay, let me just choose this. Okay. Underscore STD. Okay, 46930. This is STD. And also this will be our 100 into 30. And this one. Okay. I think now it is. Let me just see this STR. Okay. So there's no problem, nothing. I've clearly done same thing. See, now it is working. See, now it is working. There is no any problem. I think there is some, earlier it was having some problem with respect to packages, right? So while importing also you got some package like rlang was not found. And so now it is same thing. I've run it, everything. So now it is working. See, I built a model on my training data set, that is my 469 records, and I've tested it on my 100 records with respect to my column called as training labels. Means once you predict whether it is benign, malignant, you should check whether it is correctly predicted or not. Here I've specified as k is equal to 21. You can change this accordingly. I'm going to put it as 11, and here, okay, instead of here changing, I'll just copy paste into second line. One more model I'm going to build with k is equal to 11 and see the accuracy rate. WBCD underscore test underscore pred 1 I'll keep. Here I'm going to keep it as pred. Here I'm going to keep it as pred underscore 1. Now you should see what is this type of model. What type of model have you built? It should be, again, it should be in your factor type. See, because you're predicting only it as benign and malignant, right? Benign and malignant. So it is displaying correctly as B and M. B and M. So this is your model name, WBCD underscore test underscore pred. Now, once you have built your model, you should test whether it is working correctly. How much is the accuracy rate with respect to your this thing? So it's a simpler way. What you can do is you can use this model name WBCD underscore test underscore pred. See, if I run this, what you'll get? If I just run this line, if I just run the model name, what will be your answer? Give a try. If I just run WBCD underscore test underscore pred,
Yogesh, is it 100 records with benign and malignant prediction?
okay, any others?
Is accuracy rate.
Accuracy rate, no chance. If you just directly run your model name, if you get accuracy rate,
The R square
So
value.
it should give the type of the model.
type of the model, no. See here, it will give you only B and M. As Bharat said, it is only B and M because we are testing it on test data set, right? So this is your prediction of your 100 records. Prediction for your 100 records. Now, if you want to get the accuracy rate, what you should do? Bharat, can you try? If you want to check whether my model is 60% accurate, 70% accurate, 95% accurate, what I should do? Simple. What you should do by taking these records? Tell me.
Correlation coefficient. Sorry.
Correlation coefficient. No, Bharat. Think once
Sorry.
again.
No. Sorry.
See, it is simple, Bharat. This is your predicted values, right?
Yes.
You should check with your actual values, right? Yes, checking with your total records with respect to actual data. So you should take actual 100 records, predicted 100 records. So if it is B equal to B, it is correct prediction. If it is B is equal to M, it is wrong prediction. If it is M is equal to M, correct prediction. If it is a mismatch, then it is a wrong prediction. So whichever is having correct prediction, you should take that, and whichever is wrong prediction, as total number of records are 100 and how many of them are correct, you should take it. So in order to simple
We
it
need to
is, I'm going,
compare actually.
yes, obviously you need to
Sorry,
compare, right? You need to compare. You need to compare. So apart from that comparison, I'll show you one more simple method to see. This is one way to calculate the accuracy rate. So you can use a function called as G models, sorry, package called as G models, and you can build a confusion matrix like your cross table matrix. Like your cross table matrix, you can do that. Or else what you can do, first let me run this. Let me run this and explain you. Later I'm going to show you one more method to calculate the accuracy in a simpler way. See, what is the accuracy of the model? Total observation in your test data set is 100 records. How do you read this table? Explain me this table. Can anyone take initiative and explain me this table? And one more important thing is, this is your actual data and this is your predicted data.
number of patients having benign is 61% and number of patients diagnosed with malignant cancer is 39%.
Can you explain me what is this 61? Your answer is correct, but can you explain me what is this 61 and what is this benign, what is this benign, what is this 0 and what is this malignant?
That
Yeah.
61 is benign match, and then
Yes.
that 0 is benign malignant mismatch.
Okay, so simple is in your total data set out of 100 records in your test data set, you're having 61 benign patients. 61 benign patients, and there is no
Mismatch.
there is no mismatch here. Your prediction was also correctly predicted in 61 cases as benign. There is no any wrong prediction here. There is 0 wrong predictions. You can see this is 0, means there is no any wrong prediction. When it comes to your malignant in your original data set, how many malignant were there? 39. But out of 39, how
Five
many
were
you have correctly predicted?
34. 34.
34.
34 you have correctly predicted. Means 34 by 39. What about remaining 5?
Wrong prediction.
Wrong prediction. Wrong prediction. So instead of predicting it as malignant, you have specified it as what? Benign.
Benign.
Yes. So this is your wrong prediction. Wrong prediction. So how do you check the accuracy? This diagonal 61 plus 34 is how much? 5. 95 divided by total is how much? 100. It is how
100.
many percentage? 95
95%.
percentage. So if you use k is equal to 21, k is equal to 21, you got it as 95%. So let me just check it out with k is equal to 11. K is equal to 11. So here I'm going to change the model name as PRED1. PRED1. So let us try to see the accuracy of the model.
%96%.
Yes, it is 96%, but here there is one mismatch now. 3 plus 1, 4. So if you keep on changing your k value at certain point you might get a good accuracy rate. At certain point you might get a good accuracy rate. So instead of your 11, I am going to increase it to, shall I increase it to 12?
No, how do we decide the k value?
You cannot decide. You cannot decide. It is random. You should test
So
trial
we
and
need to
error.
keep trying
Rakesh. Yes. You need to keep trying until and
different
unless you
values.
get a. Yes. See, for k is equal to 12, you got it as again 95%. It is trial and error, Rakesh. You cannot decide for this problem. I'm going to use k is equal to 11, k is equal to 16. No, it is not like that.
Can you reduce the k value and check?
Yes, that was my next. So what shall I reduce? 11, you got it as 96. 12, you got it as 95.
Make to 8.
9, 9.
Probably 8.
Okay, let me just check it out for
Okay.
9. Again, it is
96.
96.
So let me try for 8 and 10. Let me try for 10 now. At least 10. 10 I'm going to try. So again it is 96. Shall I try for 8?
I think no change.
Maybe 5.
5? Okay, no problem. We can try for 5 also. So like this you can check the accuracy of your. Yes, probably you might have got a good accuracy, I guess. Yes. I think it's 97 now.
Yeah.
So like this you should keep on changing your k value in order to check whether it is correctly or how accurately your model is working. How accurately your model is working. Now, coming to, apart from this, another way to test your accuracy of the model is you can just simply write like this. This is your model name, right? One is your model name and another one is your original data. You can use equal to, open parenthesis, close parenthesis. If I run this line, what you will be getting your answer? Anyone? If you run this, what will be your answer?
True or false?
Yes, it is going to
Yeah.
give you true or false. Wherever there is true, it is correct prediction. Wherever it is false, it is wrong prediction. Instead of seeing this, you can directly use a function called as mean. So it is getting it as 97%. So one is your model name, another one is your actual data, actual column in your data. You're comparing with your model whether it is correctly predicted or not. If it is correct, true. If it is wrong, false. So this is how your particular KNN algorithm works. So I'm going to show you one simple video. I'll not record that video. This is the latest algorithm or the project what we have done it. I'm just going to stop recording